All right, in this video, we're going to talk about transformations with graphs. In order to do that, we're going to have to first study parent functions. Parent functions are basically the most basic form of every kind of equation. In fact, we're going to be studying pretty much all of these parent functions at some point throughout the course of this year. So we first need to kind of understand what they are and what they look like. So, starting with a linear function, one that we should be pretty familiar with. Our parent function would be f of x is equal to x. And again, it's very simple, just even in the equation itself. What that looks like is it just looks like a line. It's a linear function. There we go. For features of the graph, it's a straight line. There's really not a whole lot of stuff to talk about. The second type of function that we're going to study is a quadratic function. So for a quadratic function, your parent function is f of x equals x squared. And here's what the graph looks like. So some features of our graph. It's got this kind of U shape to it. Also, it's got a highest or sometimes a lowest point, which remember we've called a relative maximum or minimum. And that's got a special name. It's called the vertex. All right, our next type of graph that we'll talk about is a rational graph. So, with a rational graph, if you are thinking word parts, the word part that this comes from is ratio. And when you think ratio, you should be thinking of a fraction, which is exactly what this type of function is. It's a fraction. F of x equals 1 over x. Your graph looks something like this. So some features of the equation, we've already mentioned that it's a fraction. And typically, the variable is going to be in the denominator. So variable in the denominator. Some features of the graph, it comes in two pieces. It actually has some imaginary lines, which are called asymptotes. Okay, let's take a look at another one. So another function that we're going to be studying at some point this year is going to be an exponential function. So again, word parts, you should be thinking of the word exponent. In fact, that's what this equation is going to look like. So our parent function f of x is equal to some number a times b to the power of x. So features of the equation, you've got the variable is an exponent. And a and b are just some other numbers. We will require that b has to be greater than 1. And here's what that graph looks like. It's got this kind of J shape to it. And it will always approach 0 on one side. But never actually gets there. So it never actually reaches 0. It'll get really, really, really close, like 0.000000001. Just so close that you would think it has to cross, but it never actually does get to 0. All right, let's take a look at another one. So the logarithmic function. In this case, the parent function is going to look a little strange. You may have not seen this yet, but it's log of x. So log parentheses x. Some features of the equation, it actually says log in the equation. So it's a pretty easy equation to spot. Now, what the graph looks like is something kind of like this. So some features of our graph, it's similar to exponential, but it's been kind of flipped. And we'll talk more about that actually later on in this unit. Some other features of the graph, you do have an x-intercept, which is usually pretty easy to spot, which is at 1, 0. And that's going to be an important distinction between logarithmic and the next type of function that we're going to look at, which is the radical function. So the radical function, our parent function, is going to be one of two things. Either f of x equals the square root of x, or f of x equals the cube root of x. In fact, I'm going to do these in different colors so that you can distinguish between the two different types here. So let me do that real quick. So we'll do square root of x in red, and we'll do cube root of x in blue. So some features of the equation, we've got a radical sign with an index. The index is just the number. So for like the cube root, the index is the 3 that we put in front of it. Let's look at the graphs. So our radical function, f of x equals the square root of x, looks something kind of like this. So in a way, it looks kind of similar to the right side, if you look over here, of our logarithmic graph. But one big difference is that it starts at 0, 0. So that's kind of one big difference between the two. So logarithmic, you've actually got more to it. It also has a point at 1, 0 instead of at 0, 0. With the cube root graph, it's going to look a little bit different. It's going to have kind of some same pieces, but it looks something more like this. So it's almost as if we took our square root graph and kind of added some stuff to the left of it. And that's actually because you can take cube roots of negative numbers, but you can't take square roots of negative numbers and graph it. So there's kind of our difference. Okay, there are two more that I wanted to talk with you guys about that will come up from time to time. One of which is a cubic. And we're not going to talk too much about the features. I just want you to be familiar with the equation and what the graph looks like. So for a cubic graph, that's f of x equals x to the third power, x cubed. And your graph looks something like this. In fact, we've seen some graphs that look like this before, but this is a cubic graph. We also have what's called an absolute value function that I do want to mention. The absolute value function is actually pretty useful when we study transformations, which is what the second half of this lesson is about and what all of the following lesson is about. For an absolute value function, we'd say f of x equals the absolute value of x using two bars, one on each side of the variable. And our graph has a distinct V shape to it, something kind of like this. So those are kind of a couple extra ones that will come up from time to time that I want to make sure that you're aware of. So let's talk about some transformations. For each graph below, we're going to determine what type of function it is first, and then determine the transformation that's needed to translate each from its parent function, which is in the dotted blue lines, to the transform function, which is the solid lines. So number one, let's first identify the type of function. And this looks most similar to the radical graph. So for type, we're going to say that this is f of x is equal to the square root of x. And for transformations, if we started at this point, to get to this point, we'd have to move 5 spaces to the right. So our transformation is right by 5. For number 2, we actually just got done talking about this type of function. This is a cubic, and so I should have also written that out over here. Let's go ahead and write that out as a radical function. This is a cubic function, so the parent function is f of x equals x cubed. For transformations, we're actually going to have a couple. Let's take this point going to this point. We're going to have to move to the right by 2. We're also going to have to move up by 1. So again, that's right 2, up 1. All right, taking a look at number 3. We have to be careful with what type this is, and it's going to be important that we look at our parent function, because notice our parent function crosses at 1, 0. So while it might have been tempting to almost think that this was a radical function, it's actually a logarithmic function. So for type, we'll say logarithmic. And for our parent function, that's f of x equals log of x. As for the transformation, going from this point to this point, we'd have to move up by 1, 2, 3, 4. So our transformation would be up by 4. All right. For number 4, our type. Hopefully you recognize that this is an exponential function. So for our function, our parent function, f of x equals a multiplied by b to the power of x. And to get from one to the other, we'll go from this point and this point. So we'd have to go down by 1, 2, 3. We'd also have to go to the right by 2. All right, 2 more. So on number 5, for type, hopefully you're recognizing that this is a quadratic. So the parent function is f of x equals x squared. In fact, that's also going to be the exact same as what's over here on number 6. So I'll just draw the arrow over and we can kind of talk about these together. For the transformation, notice that from our parent function to our new function, our graph went from being wider to narrower. It kind of narrowed. And so what we would call that is one of two things. We would either call it a horizontal shrink. So horizontal shrink, meaning horizontally we shrunk it. It could also be what's called a vertical stretch. And to kind of imagine what this would be, imagine if you were to take your graph, grab it by the ends, and stretch it vertically. So you're kind of almost like silly putty pulling it out and making it kind of stretch. And when you stretch silly putty, when you pull it by its ends, that silly putty gets narrower, it gets thinner in the middle. That's the idea of number 5, is that you're vertically stretching it, you're making it more narrow. For number 6, something different happened. We took our graph and we flipped it, and we did that over the x-axis. Started to write y. But we reflected and we flipped it over the x-axis. All right, that's all I've got for you in this lesson. In the next lesson, we're going to talk about transformations, but we'll do it by looking at their equations rather than looking at their graphs. Until then, have a good rest of your day.